And we are online. Hello everyone, how's it going? Today I will be showcasing my little MRI slash CT scan volumetric viewer that you may have seen on Curtis Holt's channel today. This is a slightly upgraded version from that. I just want to go over it before I fully release it up on Gumroad and possibly Blender Market, but I'll have to see about that. But yes, here it is. Let me go and show you what it's capable of. So let's start off by just keeping this one and hide the rest for the time being, just for speed. So the way that this works, essentially, is that you have what is called a flipbook, which is essentially every single layer of the scan that you have available. Now, in the Gumroad file, I have a Blender file that can make flipbooks if you just import all the images as planes into a collection, then I'll lay them out as is. But there's other programs for that, so I would recommend looking into that when setting up your scans into that format. I recommend converting them to PNGs. There are other programs to convert either DICOM files, those are the medical files, into PNGs. You'll have to find the right one for that, but just to let you know. So you take those flipbooks, and then in this case, I used a little bit of math inside of this to stack them up. In this case, you can see I'm using 2 layers that I interpolate just like that, just to make sure that the edges are a bit smoother, but it's not 100% necessary, just to showcase this. If I switch it to there, it's a little choppier, but not too bad. Now, you can see that I'm having to use cycles with the denoiser. Unfortunately, my computer is not the fastest on the planet. I'm using an RTX 3060, which gives me okay performance, but we're missing the detail. If I let it sit for a while, then we get to see all the crisp detail. But yes, this is the shader version, which just uses shader nodes to do it, to make a volumetric in a 1x1 meter cube. This has the benefit of making booleans real time and very fast. And I should showcase that this does work in Eevee, but it's a little laggier, if you would believe that. And the volumetrics, Eevee volumetrics are not the best on the planet. So hopefully in a future update that will be fixed, but for the time being, that's the best that we've got for Eevee. Now in cycles, you get all the nice bounce lighting and all the cool gradients. So in this case, we could use this empty to go and select different parts of the brain to look at. Or another thing that you could do is take this cube and then just move it over, because that's the bounding box for this volume. So over here we can see, let me turn off the outlines for a bit. We could see the skull, the brain, the eyeball, all of that. So this could potentially be very useful for looking around in here. Even though, if you turn off the denoiser, you might be able to see more detail, but it's a little bit muddier. So I do recommend using the viewport denoiser, and then using a final render to get all the cool, crisp little details in there. I currently have my time limit for the render at 1 minute, but it still isn't 100% great. So I would recommend you fiddle around with that if you're doing this yourself. So yeah, that's how that part of the file works. So yeah, let's look at the top part of the brain. So here we can see, hopefully this doesn't gross everyone out too much, I just want to showcase it. So here we can see there's the spinal cord in there with some of the skull. I could set the color of the different parts. So in this case, I have a gradient from red to this kind of yellowy orange kind of color. I can change it to whatever I want, which is quite good. So there's that. I think I may come back to this, but for the time being, I think I'll move on to the next version, because the next version is arguably better in terms of usability. So let me turn this off temporarily. Let's unhide everything else and just focus on this version. Well, technically these two are the same, just one has the create mesh option enabled. So this one, you could add in your own shader, but in this case it's not necessary. We want to look at this part, the modifier. So I set up a geometry node system to do essentially the same thing that the shader editor did, but with geometry nodes. So in here we can set the flipbook rows, and I should have mentioned that in the original setup. But the flipbook rows, you put in your flipbook into the system, you set the amount of rows and columns that it has. In this case it has 16, as we can see up there. So you do that, and then you just have to adjust the height scale because the flipbook does not know how the distance between all the layers. You, in this case, in the geometry nodes version, you set the resolution. In this case, I have at 200 X and Y voxels. For the Z voxels, that's automatically set by the amount of rows and columns, but you could set a limiter just in case it's a bit much. You could just limit it to something like 10, just so that it doesn't freak out your computer too much. But yeah, other than that, you can control the density, you can remap the values so that you could select, oh, let's see what only the skull looks like, and so on. But here is the magic of this effect. Because it is geometry nodes, we could turn this volume into a mesh. As you can see here, I did the same thing right over there. So this mesh, it's full on just polygons. You could apply it, do anything you want. And also you could change the threshold, even though this is a little weird, I know. But you could change the threshold so that you could mesh different parts of it. I recommend using the from in and from max tools that lets you go and remap the values. So let me do that, set that to 0.5. You know, anything that you kind of want to do. It's a bit difficult to select separate layers in this version. There are ones where it works better, especially in Curtis's scan. But yes, that's how you do that. In this case, since we remapped it so that you can only see the skull, you can see all the details in there, which is quite cool. Let's see. So there's that, and I will, just for clarity, I'll show this over here as well. So in this case, you set how many rows and columns, same as the geometry nodes version, and then the height scale, just so that it's not too far stretched. If I set this to 1, it's a bit too tall. So let me go and undo that. And then again, if you set this to be the wrong value, you get a very interesting effect. Another thing is, if you set it to like a divisible by 2 version of it, then you get multiple in the same thing, which is not recommended, but kind of cool. So there's that. Again, the interpolation is recommended, but not needed. You could change the colors, and you could change the density, like which parts are visible. So in this case, when I set the density of the surrounding to be super big, that happens. So in this case, I can remap it so that this is going to be weird, so I will warn you in advance, but we're going to be seeing the brain. So if I limit this and say, let's just bring this over here, we can see the brain in all its glory without the bone being visible. So there's that, and let me remap some of the colors. Let's see, let's change this to more of a blue. There we go. Now we can see a good amount of what is happening. Yeah. I don't know why it seems to be less noisy when I make it one solid color, but I'm not complaining. But there's that. Alright, so let's go and undo that again. So that explains that aspect. Here's the part for the circular cutout, which I will unhide. Where is it? Ah, there it is. So again, if you want to do that, you could just go and cut out certain sections if you say want to see just the part of the spinal cord. So if we look in here, sorry if it gets a bit laggy, there is the spinal cord going up into the brainstem. Here, there's probably a better way to showcase this. Well, right there. But we can also limit the bounds. So there's 2 ways of doing it. Here we go. So if you ever wanted to see what a quarter of a brain looks like, you can now do that. There we have it. Let me go and undo that. Bring this over here. So yeah, many things are possible with this effect. Again, this is a little weird, And I think a little too creepy, so let me undo that by a little bit. Here's another view of the spinal cord going into the brain stem, and then the rest of the brain. So that's the effect. Now, another thing you could do is set the material. In this case, I set it to GeoShader. In this case, you could just change it to whatever you want. Pretty simple because it's a mesh. With this one, see, it seems like I kind of broke the remapping a little bit, but I forget what setting I changed. But with this one, you could just have it as a regular volume like this. But if you use the density, and since we multiplied the density over here, we have to set that to 40 as well. You could change the color and also affect the density by plugging it into this part and getting rid of that part of the attribute. Okay, I think that goes over pretty much everything. Let me just double check. Yeah. That seems to be everything. So again, here's the flipbook, showing all the data, all the slices. So we're essentially taking a bunch of 2D slices, stacking them up, and then turning them into a volumetric, interpolating them, all of that stuff. Ideally, Blender would just be able to have, say, an image sequence that you just import, and then you could just stack it automatically. But since that is not the case, I built it manually. So this file will be on Gumroad, and technically is right now, but still in testing. Which is partly why I'm doing this live stream, just so that I can demonstrate it and then see if anything needs changes. But so far, it's looking quite good. Let's see. And if you guys are wondering what this is right here, this is the quote-unquote snail inside the ear. It's the part of your ear that detects balance. As you can see, there are 3 axes, which is very, very interesting. But this was one part from Curtis Holt's scan that was quite interesting, because we were focusing on the mechanisms inside the ear for that visualization. And that turned out pretty good, so I just decided to keep it in here with Curtis's permission. But yeah, there we have it. And by the way, this is not Curtis's head. It's another one that I got online, and it should be open source, so it should be fine that I put it up on Gumroad. Let's see, you can still use UDIMs in a shader to use image sequences instead of the flipbook. I did consider using that, but as far as I know, I wanted parity for the geometry nodes version, and as far as I know, let's see, input, I don't think image sequences are an option for this one. Yeah, it's not supporting Geonodes. Yeah, I did make the Geonodes version first, and then I moved on to the shader version for this one because I really wanted to mesh the effect. So just for parity, I had the same method for both. The node setups are the same. Which, as you can see, there's a little bit of math in here. In this case, I had to duplicate it twice, so this is essentially the version. And I guess I will just briefly go over the geometry node one. As you can see, it's a little more complex, but here's the math part to just assemble the stacks. It took a while to get right. It still might be a little bit broken, but for the most part, should be fine. The image texture, the flipbook, that's what runs the entire process. This section just remaps the range and then makes it so that if you invert it, anything less than a very low value will be still invisible. That's just so that you don't turn the entire volume into geometry, just so that it doesn't like lag or crash. That's a little safety feature. Density multiplier, the height readjustment, the Z layer resolution for the volume cube, and then here's the meshing parts. Switch, set material, pretty self-explanatory. But yes, that is the process for the Geonodes one. So yes, I think I will, let's see. Maybe I should demonstrate the image packer. I think I will do that. So 1 second, folks, while I switch to that Blender file. File, open, recent. Let's do that. So this won't be like a live demo because I don't have a bunch of images that I can view immediately. But essentially this is how it works. So this is the scene, and let's say this is our test image right here. So we have this image in the images collection, place images as planes here. So ideally, you would file import images as planes. This is an add-on that is built into Blender. You just have to enable it in preferences. Then you import the images as planes with the emission ticked on, and you should be good. Just put all of them in the images collection. And then the image packer here will automatically reference that collection. You could set it yourself. And then you just decide the rows and columns that you want. If we had, say, like 100 of these, which I forget what the repeating option is. If you had 100 or 1,000 of them, you probably would want to have more rows and columns, but for this one I'll just do 6. So here, if you have too many, they'll go outside of the camera bound, so I recommend, just adjusting that until it feels right. And then you'll have all your things in a Flipbook, just render that out, save it as an image, and then it will be compatible with the main file. Again, I recommend images, PNGs. Because DICOM files, unfortunately, you can't directly import into Blender, because there's a lot of other data in those files. Fortunately, when we got Curtis's head scan, we already had, it came built in with a program that would auto-convert the DICOM files into PNGs, which was very handy, because I was searching for a program that could do that accurately. So back in the main file, yeah, that is the entire process. So yes, if you would like to download this file, in the future, the link will be in the description of this video and maybe Curtis's video, depending on how polished I can make it. And yes, just look it up on Gumroad and then you'll probably see it. What is the final resolution? In the image packer, you can set it yourself. I set it automatically to 4K. Because this is a 4K image with all of that, and it should be enough. If we zoom in here, you can see all the data. There's enough in there to do what you want, and it should work just fine. But yeah, it's very interesting seeing all of these lined up perfectly in a grid, but you can see all the data in there, and seeing it in 3D is quite interesting. Actually, just to showcase, I don't think it'll work that well with volumes, but here's the color combined with that. I set the density to be the same. You could kind of see that, but again, denoising is not having the funnest time with it, unfortunately. Another thing I should mention, just to be very thorough with this file, in cycles, if you want the volumes to be more dense, you can set the step rate for the volumes to be less, but I will warn you, it will lag. So you can see that our frames went down significantly. But it will make the volumes more dense and more viewport responsive, I guess. But if you set it higher, they'll get less dense. It's like a limiter in a way. So yes, I am holding out until the EV volumes are better, because apparently in EV Next, which is coming out later this year, should be, the volumes will be better, because as you can see at the moment, it has problems with some of the attributes with the Geonodes version. But it's alright. Actually, if you take out that part, nope, still some issues. So yes. So that's something to look forward to, and I will probably update the file to adjust for that. But yes, this is the MRI/CT scan visualizer, using volumetrics to hopefully make scan data a lot easier to view inside of Blender. So that's it. I believe I will most likely end the stream now. I'll take a few questions about this, just to be thorough. And yes, any questions? Made the Flipbook using a image magic in the command line. 16K PNG was supported. Yes, 16K would be possible with this. Well, your VRAM might be a little upset when you try rendering, but it should be possible. I just wanted something that I could include with the file, with both the blend files. Because finding a program that would do it yourself, and since I am not a manual coder, or a just regular coder, I don't do much of that. I just wanted something in Blender that I could easily just throw in, and it just works. So, it turned out pretty well. So yeah, I'll just let the render cook a little bit more. And it actually looks like a 3D print in some of these situations, or a, what was that called? A ballistics dummy, as they had in Mythbusters. But yes, many things are possible. Again, just for clarity or thoroughness. If you want to apply the modifier, you just click this little button and press apply, or you can use the hotkey Control A. Then all of a sudden you have a mesh that you could do essentially whatever you want with. Maybe smoothing it out a little bit, because I assume those layers are not a problem with my node setup. There's a chance it is, but I will fix that if that is the case. Just a little bit of smoothing. There do seem to be a few little holes, and I guess that's from either the remeshing not being 100%. Let's see what happens if I up the resolution to, if you set it up even higher. Most of those go away, but you get a few little more, just slicing issues. So yeah, that may be improved in the future if I can't figure out what the problem is. Okay. So I think that's it. I will wrap up this stream for now and maybe post it later as a proper edited video. But thank you all for watching again for the third time. If you would like to download this file, it will be up on my Gumroad page, and the link will be in the description. Again, special thanks to Curtis Holt for letting me develop this tool with his own brain scans, which was very interesting to look at. Lots of very interesting data that we were able to go over. Alright, thank you all for watching, and I will see you all next time.